Welcome to this live and broadcasted version of Digested News from Genovis. My name is Jonathan Sjögren and I've worked at Genovis now for the past 5 years. Today we're broadcasting on YouTube, and to give everybody a chance to watch some recent updates on the Smartenzymes applications, and today we'll focus especially on the IgG proteases. There is an option to ask questions during this seminar, and you can do that by writing in the chat function live on YouTube, and we'll take perhaps some of these questions towards the end. So first, a quick note on Genovis. So Genovis is a Swedish biotech company. We're located in Lund, in the very south tip of Sweden. We've been providing Smartenzymes for biopharmaceuticals since 2010. And all enzymes are manufactured, developed, produced, and QC tested here in Lund, but we also have presence in the US, in San Diego, and in Boston. For the Asian markets, we work with partners distributing our products. So anywhere in the world, you can buy and source the Genovis enzymes. So anyone working with biologics or biopharmaceuticals knows that these are very complex and large molecules that are hard to characterize and hard to work with. So during the past years, we've seen a tremendous success of especially antibody therapeutics. And coupled with that, we've also seen a trend growing of increased resolution of mass spectrometers, meaning that we can analyze and see very fine details of our molecules. That has created a need and a gap for very good and specific sample preparation. And that's where Genovis Smartenzymes are used. So today we'll focus on 3 applications. We'll talk about middle-level analysis of antibodies. We'll talk about automated generation of these antibody subunits, and lastly we'll talk about above-hinge digestion. So first, what is middle-level analysis? So by using traditional enzymes, there is a lot of sample preparation that goes into characterization of an antibody, for instance. So typically there is a lot of sample prep steps. You need to reduce, alkylate, and then perform a digestion over a long time. And the LC-MS run also takes significant time, that generates a very complex data sets that needs to be analyzed. And because of these long sample preps and the complexity of the data, there are limitations in how many samples you can process. But with the Smartenzymes technologies and with the middle-level analysis, you can take an antibody and cut it into very defined pieces that are easily analyzed on LC-MS instrumentation and also easy to interpret. That means that you can process many samples in very short time, such as in the example here. First, we'll have a look at the FabRICATOR enzyme. So FabRICATOR is a cysteine protease, and it's coming from Streptococcus pyogenes. And this is a pathogen that lives in the throat of us. It has one substrate, and that is IgG. And there's no other substrate known. And the way this enzyme works is that it binds to the CH2 domain, then reaches the hinge and cuts. And in this way, it has a single digestion site in that hinge region. That means that there is no over-digestion and there is no optimization needed. And that's why it has become a platform method for a routine analysis of therapeutic antibodies. The incubation time is fast. It's typically 30 minutes at 37 degrees, and it works in most physiological buffers. And the workflow that many people use is what you see on this slide. So you start with the intact antibody, digest it, cut it in half with FabRICATOR to generate the Fab'2 and the Fc half fragment. Then the sample is reduced to go to the subunit level. And now you obtain the FD, the light chain, and the Fc half fragment. All of these fragments are roughly 25 kilodaltons in size and fit perfectly to analyze with an LC-MS instrumentation. We'll have a look at one example of this. So this is from Izabela Sokolovska and her colleagues at Janssen, and they are using FabRICATOR in combination with IgG0 to take a therapeutic antibody, cut it below the hinge, to generate the Fab'2 and the Fc half, and at the same time trim down the glycans of the Fc. Then a reduction step is added to go to the subunit level. And now these subunits can be analyzed and focus on the oxidation status. So to the bottom left, you see that if you increase the amount of paracetic acid to your sample, you will induce 3 oxidation spots in the Fc half fragment. And then you can separate these on reverse phase separation. So you'll see the single chain Fc, the light chain, and the Fd. Then you detect these masses with mass spectrometry, then deconvolute the data, and now you can see the oxidation as a +16 difference on these molecules. And now just a couple of weeks back, there was another publication from the same team at Janssen, and they have now tested this assay in 3 different labs in 3 countries, and it's now an approved assay for GMP compliant quality control. So the workflow is the same. The antibody is digested and deglycosylated, reduced, and then analyzed by LC-MS to study the oxidation of the individual subunits. And by applying this workflow, Izabela Sokolovska and her colleagues writes that they obtain a faster and more robust workflow as compared to traditional peptide mapping. So we'll switch gears a little bit and talk about the FabRICATOR-HPLC column. So this is an idea that we had, that we wanted to connect the bioreactor to the mass spectrometer and to obtain an online digestion and separation and analysis of the therapeutic antibody. And to do this, we mobilized the FabRICATOR enzyme on a porous resin and put it into this HPLC column format. And by doing so, we can automate the subunit generation, get a digestion of IgG in under 5 minutes, and also reduce sampling handling and errors. So we're not there yet to have connected this to the bioreactor, but we've developed a workflow that can take a therapeutic antibody in the autosampler, pass it over the FabRICATOR-HPLC column, where the antibody is digested. You'll obtain the Fab'2 and the Fc half, and then the antibody will go into the reverse phase column where it gets trapped. And then we'll add TSEP to those trapped fragments that will become reduced, and then the mobile phase is added to separate the fragments and then go into the mass spectrometer. And the type of data you can obtain using this workflow looks like this. So we'll here compare the performance of the enzyme to the HPLC column. And as you see, the data is overlapping. You see a small asterisk there on the light chain, and that is to a non-complete reduction of the antibody. We also wanted to test if we could use this column over a 14-day period at 37 degrees and continuously inject samples on the column. And we saw that the enzymatic column performed very well during these 14 days. And when we compared the data, it was overlapping to the one of the lyophilized enzyme. And lastly, of course, carryover is very important. So we injected trastuzumab and then a blank and then trastuzumab again and then switched to a second antibody. And we couldn't see any traces of that antibody in the next injection, meaning that there's no carryover over the FabRICATOR digestion column. So very recently there was a paper coming out from a talented postdoc at Genentech, Julien Camperi, in collaboration with his colleagues at the University of Geneva and the group of David Guillaume. And what they've done is to apply this column to a similar setting as we've done. So take the antibody, pass it over the FabRICATOR column, and then do a reverse phase separation and into mass spectrometry. The difference is here that they don't reduce in this example. But they applied this workflow to a bispecific antibody. So now they have an antibody that recognizes 2 different epitopes. And by doing so, they could, when analyzing the data, they could see both light chain pairing and mispairing. they could see glycations or C-terminal lysines. And the samples they used came from process development. So they could also detect, as indicated by small asterisks here, process impurities. So by using this fully automated workflow, they get a very good picture of the quality of the antibody and also any impurities that's coming along. This team also pushed this one step further and added a second dimension in the separation. So in total, you could call it like a three-dimensional approach. First, you digest the antibody, then you do a reverse phase separation, and then a helix separation. And by doing so, you get a fully automated digestion and separation, but you can also separate then out the Fc glycoforms on helix and make it easier for the mass spectrometer to detect every single glycoform in that Fc half fragment. So to summarize the FabRICATOR-HPLC part of this talk, we have now this HPLC column. It's, as I mentioned, fabricator immobilized to a porous resin. The typical flow rates are very slow, so you don't build up any pressures over the column. The column can tolerate then, as we've shown, 37 degrees over prolonged periods of time. And we've done over 200 injections on this column, and it works fantastic. And the starting material here is, you need a human IgG. You could be an ADC or a bispecific or even an Fc fusion protein. But as long as it has that Fc part, so that fabricator can bind to the CH2 and reach the hinge and cut, then it will work. So now we'll switch enzymes and talk about FabRICATOR. So FabRICATOR comes from a pathogen that's related to Streptococcus pyogenes, but that primarily infect cows and make them unable to produce milk, alactic. That's why we call it FabRICATOR. And this enzyme binds in a similar way as the fabricator to the CH2, but then reaches above the hinge and cuts the antibody into two Fabs and then the Fc. It's specific for human IgG1, and it will require an overnight incubation. But it has a very specific digestion site, and there is no over-digestion, even after an overnight digestion. Also, it doesn't require reducing agents, which is very important. We'll show that later. So here is a very recent example from Sanofi, where Alessandro Masiero and Nelly Lechat and colleagues at Sanofi in Paris, they have a multi-specific antibody. So this is an antibody that has 3 epitopes. So one Fab arm and then another Fab arm that recognizes 2 sites. So in total 3 epitopes. And when they have this type of complex antibody, it's very beneficial to cut above the hinge, because then you generate the single Fab and then the Fab with the 2 recognition sites. So here we show the mass spec data that went into this paper. But they used this FabRICATOR digestion to identify a proline trans-cis isomerization, and using size exclusion chromatography coupled to mass spectrometry. And by doing so, they could say that, oh yeah, this is the fragment where the heterogeneity is coming from. Another French example of using FabRICATOR is this paper here from Valeg Faid and his pals at LFB Biotechnologies. So what they've done is to use FabRICATOR in combination with FabRICATOR. And the nice thing about this is that they both work under non-reducing conditions, meaning that you will obtain above hinge and below hinge digestion without messing with the disulfide bridges. So in this example here, they took an IgG1 antibody, digested it with FabRICATOR fabricator under non-reducing conditions, and then looked at the integrity of the disulfides. And by doing so, they separated this on reverse phase using a diphenyl column. And then they get a hinge peptide, then the Fc fragment, and then the Fab. And these will then separate differently depending on how well the disulfides, if they are bound together or if they are open. And this could be applied to a range of different IgG1 antibodies. And you can then detect and monitor both intra and interchain free sulfhydryls. But it's all based on those single digestion sites and that both enzymes work under non-reducing conditions. So we'll start to summarize. So we've talked about a couple of examples here of using the Genovis Smartenzymes to analyze therapeutic antibodies. So we've talked about subunits, LC-MS, antibody oxidation assays, the examples from Janssen. We've also talked about automated the antibody subunit generation using FabRICATOR-HPLC. And lastly, we've talked about FabRICATOR for above-hinge digestion of multispecific antibodies, and also for a label-free disulfide analysis. So there are, on the Genovis website, there is a ton of material. So we have application notes, we have more proteases that we didn't have time to go through today. We also have product information, posters, instructions, specifications, certificates of analysis. Everything you need is on genovis.com. But if you have any questions, you can contact me directly. Here's a picture of myself, that's great. And then we have contact email info@genovis.com. But you can also contact our excellent support team at support@genovis.com. And that's it. And we'll see if Felicia has a few questions.
Yes. Hi, so my name is Felicia and I work as a product specialist here at Genovis. So I have a few questions here that are regularly asked about these enzymes. The first one is about FabRICATOR. So can FabRICATOR be used to digest ADCs?
Yeah, absolutely. So as we talked about with the FabRICATOR-HPLC column, FabRICATOR needs that CH2 domain and also the hinge to be able to cut. But it's routinely used for analysis of ADCs, both randomly labeled and also site-specifically labeled ADCs. So absolutely, yeah.
Great. So the next question is about FabRICATOR and FabRICATOR. Can these two be added in the same digestion?
Yeah, that's a great question as well. So many of these enzymes come from related pathogens. So they're designed by nature to work in combination. So FabRICATOR and FabRICATOR come from different pathogens, but still they can work together. So as in the example by LFB Biotechnologies, they first added the FabRICATOR enzyme, performed the overnight digestion, and then for the last half hour, they spiked it with FabRICATOR to get the below hinge digest. So absolutely, that's possible.
Great, thank you.
All right, so then I think we'll wrap up here. Thanks so much for watching and keep on digesting.